is about the geometric application of integrals, or in other words, how to use integrals to compute properties related to geometric forms or objects. Okay, so we're going to see how to compute areas of figures, volumes of figures, and also some lengths as well. Okay, so we'll start with the area of flat figures. Okay, something like this, areas in 2 dimensions. And so we can imagine a form given by this, right? Two how to say, the borders defined by 2 different functions g and f, right? So it's pretty straightforward to see if you realize what the integral of g from a to b is doing and the integral of f from a to b is doing, is that the area of this form S is just the integral between a and b of g minus f. That's the function, right? That's the value of that area, right? And that's going to give us a positive value, actually, right? But the thing is that this is not general, because sometimes we have a function g like this and f like this that cross over, okay? And we want this, the area of this formula, that you want these 2 areas, right? So what we want to do is actually find the intersection, so the point where f and g intersect, so that here we want, this is f here, right? And this is g. So what we want here is the integral between a and this point of intersection of f minus g, and here is this integral between this point and b of g minus f, right? So we can write this in a general way like this: a of this form S, right, is the integral between a and b of the absolute value of g minus x or f minus g, it doesn't matter, right? And so in order to compute this in actual examples, right, this is the formula that we're going to use. In order to compute this, we need to find where the this absolute value is going to be positive or negative, right? I mean the argument inside. Okay, so for instance, as an example, let's compute the area between this function f, which is x times x minus 2, and g, which is x over 2, right? So now this is a parabola, right? That is doing something like this, and g is doing something like this, right? So between the interval 0 and 2, right? Well, actually, what's going on here? This parabola, right, is a positive parabola that does something like this. Between 0 and 2 is negative, right? And then this x over 2 is something like this, right? So this is the area that we want. Sorry, this area, not to here, right? This is 2, this is 0. This is the area that we want. So here it's obvious that g is greater than f for all this interval between 0 and 2. So what we want is the area of this form S, right? S is the integral between 0 and 2 of x over 2 minus x times x minus 2, right? And well, we can expand this. This is x squared minus x squared plus 2x, right? This is what we have. And so the integral of this is obviously x squared over 4 minus x cubed over 3 plus x squared. And all this we have to evaluate between 2 and 0. So you have 2 squared over 4, 1 minus 8 thirds plus 4. And then at 0, all of this is 0. So we have 1, this is 3 thirds minus 8 thirds is minus 5 thirds plus 12 thirds is 7 thirds. That's the area of that particular figure. Okay, and then and let's do another example where there is an actual intersection. Okay, for instance, we have this function f is x and g is x cubed over 4 in the interval minus 1, 2. Okay, so in this interval we have that x is doing this is f, and let's see, at minus 1 this is doing something like this, right? This is like this, and this is like this. So between -1 and 2, let's see, we have this and this, right? Let me first prove this, right? This is the area that we want. This is -1, this is 2. How do I know this? Well, let's see where these two functions are equal, right? So where is x equal to x cubed over 4 or equal to 4x, right? So this is equivalent to x cubed minus 4x equals 0, which is equivalent to x times x squared minus 4. So the solutions of these are x at 0 and then x equal plus minus 2, right? So these are the 3 points of intersection, right? So between -1 and 0, we have the g, right? As this the cubic polynomial is greater than f, and between 0 and 2, f is greater than t. Okay, so we have the area of this function is between -1, the integral between -1 and 2 of the absolute value of g minus f. What we know, because we have evaluated those, is that this is, we can separate in two integrals between -1 at 0 of x cubed over 4 minus x dx, which is greater than 0, and then plus the integral between 0 and 2 of x minus x cubed over 4. Okay, and so here this is going to be x to the 4 over 16 minus x squared over 2 evaluated at 0 and -1, and then plus the integral, let me put some brackets here, the x squared over 2 minus x to the 4 over 16. Okay, and again now evaluated at 2 and 0. Okay, so this is at 0, this is 0, and then we have -1 is let's see, is 1 to the 4 is 16, right? So this is -1 over 16, sorry, and then minus plus 1/2, and then we have plus 4 over 2 minus 2 to the 4 is 16 over 16, 1, and then at 0 it's 0. So this is 2 minus 1, 1 plus 3 over 2 is 16. So this is 48 over 16 minus 1 is 40. Wait a minute. No, yes, sorry. So this is 2 minus 1 is 1 plus 1/2 is 3/2, which is equal to 24 over 16. Minus 1 is 23 over 16.